Throughout history, architecture was influenced by technology. Gothic arches and vaults made it possible to buildings much higher than before. Steel frames and elevators made it possible to build them even higher and brought us skyscrapers. Last century, computer-aided design was brought, and it was the last leap in this technologies. Since then, we haven't seen many game-changing technologies in architecture, and we think robotics is the next one.
One of the good ways of implementing robotic system into the construction industry is additive manufacturing technology, which has been proved as a very powerful tool when it comes to the moment that you need to produce very complex shapes. But usually it was the case just in the small scale. Our focus within this project was also to investigate applying additive manufacturing to the large-scale fabrication.
We see robots that are independent of the size and the shape of the object they create, that are small and agile, and each of these robots can do its own task. We decided to make a group, a community of robots, which have their own tasks and that are small but can create very big structures.
The first robot has 2 tracks and the CNC, that the nozzle is fixed on the CNC. The nozzle can go up till 15 centimeters, and this is how we create our first 15 centimeters of the structure. In the front of the robot we have ultra-red sensor that recognizes the path on the floor, on the ground, and it follows the track. It follows this line, and this is how it prints the first layers.
So this is the second robot, which clamps onto the layers previously printed by the first robot. With this mechanism, it clamps onto those first layers, and then these servos are then rotating the rollers, which is pushing the robot around that already printed structure. As it's going around, the really special thing about this robot is that it's printing on the layers it's already printed. In this spiral that it's printing, it's then constantly going over the layers that it's already printed. This mechanism here then clamps onto the layer that's already been printed and gives us the opportunity to control the shift. If we want to print a structure which is just a column vertically in Z, then we will keep this in the center and we will just continue printing. But the moment we want to do a curvature, we can then shift this nozzle slightly to the side, maybe 1 or 2 millimeters, which incrementally gives us the ability to then print a curvature along the structure.
So after the first shell is done, the third robot is gonna print on top of the first layer, and it's gonna move freely on it, even it's upside down. This is enabled by a vacuum generator here and a suction cup at the bottom of the robot. When it's printing, the generator, a rotor inside is gonna rotate very fast, so it's giving a low pressure of air at the bottom. Unlike the previous layered robots, this one is not gonna print horizontally and parallel to the previous layers. This one is gonna create a freeform curve. For this pavilion, it's gonna apply material on specific regions and freeform curves.
This swarm robotic 3D printed prototype is an effort of bringing additive manufacturing into construction scale. We know very well that additive manufacturing has been influencing a lot of disciplines such as medicine and such as product design, but we as architects, we are very much into investigating how this technique is going to change the way we construct. It's very important for IAC and the research agenda within the additive manufacturing to bring industries and to bring companies within the projects that we are developing. We really consider that in order to achieve innovation and new ideas and projects, we need to bring together academy with industry. And that is what we are trying to do within the Open Thesis Fabrication Program. And that is what we're trying to do with this project developed in the last 6 months here at IAC.